Thank you very much for taking the time, and we will be discussing the weekly status update for the Canadian retail food price analysis brought to you by BDAT Data Sciences, and this status update is for February 20th, 2024. I am Grant Friend, the project manager, and I'd like to take you through the recent progress on this project. So today's agenda, we'll be going over the project summary, just a brief reminder of what our purpose is, the profile, our timeline. We will provide then some recent progress updates in regards to just current progress, tasks, challenges, and upcoming items. We'll also be discussing data architecture, data cleansing, and manipulation. And you'll be given an introduction into the recent progress in the code by our programmer, Sarath. Then I will be transferring over the slides to Chirag. Chirag will take you through the EDA visuals that have been created, and also a friendly reminder on the budget status and then any additional communication that may be needed. So, as a reminder, our project summary is this. Our team is looking to complete an in-depth analysis of any historical retail food prices within Canada, then also layering that potentially with the CPI data that we're also receiving from Stats Canada and seeing if there's a correlation between the two. The end objective is to essentially provide a proposal to the Bank of Canada in regards to interest rate hikes, potentially impacting CPI, and then also seeing what kind of impact that can have on the pockets of Canadian residents. So as mentioned, my name is Grant Friend. As you can see, here is the team lead on the left side. And then here's the main tasks. Then we have our business analyst, Chirag. Then we also have our programmer, Sarath. As you can see, here's the profiles and the responsibilities. Here we have our Gantt chart giving just a general overview of the current progress that's been made. So as you can see, we've closed out of the design phase. We're now in the development phase, and we're about, I'd say, 2/3 of the way through that. So progress is definitely heading in the right direction, and just showing that everything is essentially running smoothly. So, as mentioned, progress. So current summary of our tasks, we've managed to create an automated data pool for both the CPI and the retail food prices. We've also completed some data cleansing and manipulation. As mentioned, Sarath will give a walkthrough on that. A lot of new variables have been created and null values removed, so on and so forth. The EDA process, exploratory data analysis, that is just, we're going to highlight some visuals and also just some kind of callouts that can be made within the data. We also have an aggregation of data for retail food prices, kind of bucketing them into baskets, meat, dairy, other, so on and so forth. Then also a nice little data dictionary was also completed. Current tasks, determining variables to be used in predictive models. So now that we've essentially gotten a better understanding of our data, we're now looking to do the predictive model phase. Threats that were impacting us is normalizing the data, any challenges due to only having one numeric variable, and also just an understanding of the segregation of duties and responsibilities of the team. Activities to be completed by next week, development of the predictive model. As noted, we're moving on to that phase. So in this slide here, we're looking over just a very, very high level of tech stack / the data architecture. So realistic retail statistics with raw data using Python, we're able to bring that into Jupyter and also utilizing Google Colab. We'll then manipulate the data and eventually get it to a BI visualization engine in Power BI, and then eventually hand that over to the Bank of Canada. So here we have just some screen grabs of the raw data. These hyperlinks will actually take you right to the raw data itself. And then within here, you're starting to see this is the autoload script. So the front one here is the CPI, back one is the retail food prices. So if I just quickly take a look at that, it'll bring us into the Google Colab. And so that's where Sarath will give a nice breakdown of this. As mentioned, the hyperlink for the StatsCan raw data. So this is like the very true raw form of our data. My apologies. So then what we have here is also the multiple stages of the data manipulation. Again, further detail will be provided on those from Sarath. So just get an understanding of just kind of the heavy work that was involved, especially with the aggregation of the baskets. And so last but not least, on the EDA component, just kind of some snippets of some steps that were created. So getting a better understanding of the information and data broken down by both columns and numeric variables, taking a look at the data types as well. As you can see, we basically only had one true variable that we could utilize, which is the food price as a numeric variable. Trying to get, starting to play around a little bit, trying to get an understanding of our unique variables here. As you can see, this brief little screen grab. And also looking at location, like which ones from a food price perspective, so that's a retail food price. Trying to get an understanding of what provinces were impacted on average over our complete timeline. So that was 2017 to present. And then last but not least, just trying to get a look at the box plot and how the performance is, here's the two numeric variables that gave only the food price. So not really too much information is, of great value here. And I thought just adding in just a quick little snippet of, what was our most expensive product you can see here was the instant formula for the baby formula for Newfoundland back in June 1st of 2023. So Some quick and interesting findings were definitely provided through the EDA process. A lot of work from our program, a lot of heavy lifting was done. So I will now provide this over to Sarath for him to be able to walk us through the logic he created. Thank you.
Thank you, Grant. Let me take it over from here. I'm going to show a demo about the data manipulation and data cleansing activity. We are using Google Colab for this task. So the first step would be importing all the required libraries for executing the code. And we are using StatsCan library, which is a library used for pulling the data automatically from StatsCan website, which is available as a Python SDK. I already executed this block. Let me rerun it again. So now the block is running and the code will be completed. Yes, the code is completed. Now we are imported all the required libraries. This is the next block where we are downloading the average retail food price table from StatsCan website. This is the product ID, and each and every table associated in StatsCan website will have a unique product ID. So this is the product ID for average retail food price table. We're going to download the data from it. Yeah, we have the raw data collected as a data frame. We have a lot of columns, so we are not interested in every columns. We are interested only these five columns, which is date, geography ID, geography identifier, and product and value. These are the required column for our analysis, and I'm going to execute it. So now we have the five columns filtered out. Next step would be splitting the product and the unit from the products column. So we have a product here and the respective unit here. So we need to do a simple data manipulation for this activity. So once we executed this block of code, we got the product and unit split out into two separate columns, but still the name is mentioned as 0 and 1. This is a default naming convention. So we're going to apply a renaming. Yeah, now the data is properly renamed. Now we have a date, location, geography, ID, food price, product, and unit. This product duplicate column, this product column is removed. So now we have a cleansed data now. Let's go to the next data manipulation activity. For doing this data manipulation, first we need to identify what are the anomalies present in the data set. So I'm going to comment the code and want to see how the data looks like. The anomaly which we are intending to find is finding the product where the unit is null. We have a product called tbag where the unit is actually showing as null, so which is not good for doing data analysis. So we need to do some manipulation on that. I written some methods to download the file. So this will be useful to download the entire file as a CSV and show it on the local system, because the data frame will show only 5 rows, 10 rows only. So as you can see, so those are around how much 925 rows which have the tbags column associated with that. So now we need to apply logic to properly clean the data. So let me comment this line of code and see how the logic looks like. So we have a method to handle that anomaly. And let's see, we have a verification code here. Let's see how the data now looks like. So after running the code, there is zero anomaly. Now there is no anomaly record. There is no unit column with a null value. And we can even download the data to see how it looks like. Yes, let me run this block. Updated data set. The code is running now. Yes, the data is downloaded. Okay. Updated data set is downloaded. Let me open it. Yeah, it's opening. T. Yeah. So as you can see, the product T and the unit is properly split out. So we are good with this cleansing activity. Now let's move on to the next code. In the next part, we're going to check on the product which are having the unique values in it. Let's run the code, and we got the unique product. I already pasted the data into Google spreadsheet to see. As you can see, if you go to the bottom of this data set, there is some 4 products which appears to be non-food products, detergent and shampoo, and also we're going to apply a filter to remove those. So we just remove all those columns, and we checked those columns are perfectly removed from the data frame. The next data manipulation activity is applying the proper volume and measure for the unit that we collected. There is a column with value we have like a 1 kilogram, 10 kilogram. We need to properly split those unit and the volume and measure from that. So this is a logic for that. So after executing this logic, we are properly splitted the volume and measure into separate columns. and we have formatted the data into float type with a number type. So now the next step would be, after doing this also, we have one more anomaly, which is the measures are not having the standard unit for every product. So let me run this code and show you. So in this code, you can see kilogram, grams, kilograms. So this is not a standard measures. So we need to normalize this measure. So for that, we have a method here to normalize the data. And let me run this code. Now let's see how the measures are looking. So now we have proper measures, only 4 measures are there. And let's come to the final logic, final data manipulation logic on the food price data. This is a logic where we are going to apply a category for each products, like canned food products, meat, dairy, oil, like that. And for me specifically, we have a subcategory. So let me run this code. Yeah, this is our method, and let me run the code again. This block we have properly spread out the product category. So as you can see, beef stew cut, which is the product, and the product category is meat, and the meat type is two cuts. So we have split out the product perfectly. And this is all the EDA. I think Grant and Shreya are going to explain about that in the slide. And this step they will explain in the slide itself. Let me go to one EDA, which I like to explain about average meat price over time by meat type. So as you can see, you can see that people are mostly consuming chicken breast, chicken drumstick, and salmon over the last 6 years. This is the most consumed meat. This is an area we want to highlight. And this is our step to download the final data set. So if we execute at this block, we'll get the final data set cleansed food price data. And this data will be uh, used for doing our Power BI dashboard. And the next step would be downloading the CPI data. This is the product ID for CPI data. And this is a filter to filter only the food products from the CPI data. And we have applied the necessary filter. Food category filter is applied, and the date filter is applied. We are interested only data from 2006, because this CPI data having data set from 1960s onwards. So we don't care about the older legacy data. So we just apply 2006 onwards. So now we can see we have all the necessary columns, and their respective values are present here. So this is the end of our demo session. I will let Chirag and Grant to explain further about the EDA stuff. Thank you.
Thank you, Sarath and Grant, for your presentation and demonstration. Now I'll walk you through quickly on our EDA and visuals. We have two charts, as we can see on the screen. We have two charts. The first one is showing product category with its price, and the second one is about the meat type with its price. From the first chart, it's clear that the most expensive food type is meat. Now I'll jump on to next slide. If I talk about our budget status, then initially we had less budget hours, but with the time we are having more hours in requirement phase. So if I talk about till now, till date our cost, then it's about 19,500, and our charge is about 300 per hour. If I talk about communication, then we mostly do our communication from Microsoft Teams. Our last meeting was conducted on 13th of February on MS Teams, and we discussed about our EDA and segmentation of our work. Feel free to ask questions. It's important for feedback. I'm gonna skip that part because this part has been already demonstrated by Sarath. I'll quickly jump onto the last slide of this demonstration. So if I talk about callouts from our project, then Ontario has experienced the lowest increase in medium retail food price among all the other provinces. If I talk about BC and Newfoundland, which has experienced the first and the second highest increase in median retail food prices. If I talk about years from 2017 to 2023, then food price has increased almost 50%. And last but not least, the baby formula in June 2023 from Newfoundland is the most expensive retail food product out of the entire data set. So that's all from my end. Thank you so much